Remember some times ago at the beginning of the semester, we were actually doing something about finding the limit. And typically the troublesome case when we try to find the limit is that when we have the 0 over 0 and infinity over infinity. And typically, I mean, at the beginning of the semester when we don't have much tools yet, the only way that we can deal with this kind of tricky situation is that we have to simplify or we have to rely on some algebraic properties to actually do the limit. So now that we are done with the derivative, we are actually going to use the derivative to help us find the limit. So we have with us here a L'Hopital's rule. A L'Hopital's rule said that if the limit of f and the limit of g, they are both 0 or they are both plus or minus infinity, then the limit of f over g is going to be the same as the limit of f prime over g prime. So one thing you will need to take note of is that I'm talking about the limit of f over g equals the limit of f prime over g prime. So there's two things, I mean there's a few things I'm gonna have to point out. I'm finding the derivative for the numerator and the denominator separately. So that's the derivative for each numerator and for the denominator. So I'm not finding the derivative of the fraction. I'm finding the derivative of each part. So this is not the derivative of f over g. This is the derivative of f divided by the derivative of g. And the other thing is that I'm gonna need, for L'Hopital's rule to work, I'm gonna need the limit of f to be the same as the limit of g. And that can be either 0 or that can be either plus or minus infinity. So that's one of the things I said in the hands up. The other thing is that the limit that you see, I did not put any direction or anything up there. So the limit can be so it literally can be anything. It can be the limit when x goes to 0. It can be the limit when x goes to infinity. It can be the limit when x goes to minus infinity. It can be the limit when x goes to any constant from the left, from the right, or without the direction. So for the practical purpose, any limit you see is actually gonna work. And 3, just like I said up here, you need, when you want to use L'Hopital's rule, you want to find the limit of f and g and divide them, not the limit of f over g. So this actually, we do the easy one, not the hard one. You can think of it that way. So, okay, let me try to do this example here. Okay. I like to find the limit of x squared minus 4x minus 5 over x minus 5. Well, when x go to 5, what is this thing? So let me plug 5 into the equation. 5 squared minus 5 times 4 minus 5, that's going to be 0. 5 minus 5, that's going to be 0. So I have 0 over 0. So that means this is something that I can use the L'Hopital's rule. So this is going to be the same as the limit when x go to 5 of the derivative of the numerator divided by the derivative of the denominator. Derivative of the numerator is going to be, let's see, it's going to be 2x plus 4. The limit of the numerator, the denominator is going to be just 1. So again, I do two things. I check that it's 0 over 0, and then I find the derivative of the numerator and the denominator. What does that give me? When I plug 5 into this guy, I get 6 over 1, so that's just 6. So that's the L'Hopital's rule, and you can see it's not too bad. Let me do the other one. I have 2x to the 5th minus x cubed over x squared plus 7x. If I take the root, if I find the limit, I plug in x equal to infinity, I get infinity over infinity. This is bad. So I use the L'Hopital's rule. This is going to be the same as the limit. Well, I take the derivative of the numerator, so that's going to give me 10x to the 4th minus 3x squared over, 2x plus 7. This is going to be the limit when x goes to infinity. So, I plug in x equal to infinity again, I find the limit of this guy, I once again get infinity over infinity. So that means, I don't have the answer yet, but what I can do is, I can use L'Hopital's again. And so because the same things apply, I find if I want to find the limit of this guy, it's just the same as the limit of this guy, but to find the limit of this guy, which is infinity over infinity, I can appeal to L'Hopital's rule, and that's going to give me the limit when x goes to infinity of, 40x cubed minus 6x over 2. And now I can easily compute the limit of this guy. It's going to be infinity over 2. So the whole thing is just going to equal to infinity. So essentially, in reality, it's not too hard to find the limit of the first two. You can actually factor these guys and find or use the algebraic manipulation to find these limits. So the next example is going to be where you can factor these terms to actually find the limit. So if I were to plug in x equal to 0, you are going to get, you're going to get 2 to the 0, that's going to be 1 minus 1, so that's 0 over 0. So we once again have this 0 over 0 form. So I'm going to be using once again the L'Hopital's rule. So that's going to be the limit of, the derivative of 2 to the x, that's going to be 2 to the x log of 2 over the derivative of x, which is 1. Now I can plug in x equal to 0, and I'm going to get 2 to the 0 is 1, so that's actually log of 2. So that's not too bad. Let me try the next one. I need to find the limit of sine of x over x when x goes to 0, and once again, you get 0 over 0. So I use L'Hopital's rule, so that's going to give me the limit of x to the 0. And the derivative of sine, that's going to be cosine. The derivative of x, that's going to be 1. when x goes to 0, cosine of x equal to 1. So this guy gives me 1 over 1. 1 over 1, you don't need to use L'Hopital because 1 over 1, that's going to be just 1. So the next one, I like to find the limit when x goes to 0 of 4x minus 5 over x minus 2. So if I plug in x equal to 0, that's gonna give me negative 5 over 2. So the limit of this guy is actually just gonna simply be what I have up there, negative 5 over 2. So negative 5 over 2 is a number, it's negative 2.5. So that's a legitimate answer for this question. However, note that if you try to use the L'Hopital here, the wrong way to do this would be saying that that's equal to the limit when x go to 0 of derivative of the top, which is 4, over derivative of the bottom, which is 1, and that gives me 4. And you can see this is not the same answer. And the bottom one is not correct. So whenever you try to use L'Hopital's rule, remember that you actually have to check the limit firsthand to see if they are in one of the form that you can apply. If it's not 0 over 0 or not infinity over infinity, then you cannot use L'Hopital's rule. So again, let me try the next one. I'd like to find the limit when of x equal to, this is the same function, but x go to negative 2. Well, if I plug in x equal to negative 2, I'm gonna get, let me see, negative 8 minus 5, so I get negative 13 over 0. So again, I'm not seeing 0 over 0. I get negative 13 over 0. So I once again cannot use L'Hopital. If you were to sketch the graph for this guy, it's gonna look something like this. So it's gonna go to infinity in one direction and negative infinity in the other direction. So this is the limit without sign. So when this case happens, that's gonna just the limit just doesn't exist. Let me now try the next one. I have something a little more complicated now. I have the limit when x go to infinity of x squared over x minus 1 minus x squared over x plus 1. So this guy doesn't just have one fraction, it has two fractions. But let me actually let me actually plug in infinity to see what I'm gonna get. I'm gonna get infinity over infinity minus infinity over infinity. So it looks kind of funny. So maybe it's a good idea if I try to simplify the guy here first. So let me do that. So this is going to be the same as the limit when x go to infinity of, let's see, x squared x plus 1 minus x squared x minus 1 over x plus 1 x minus 1. Okay, let me keep working on it. On the top, I'm gonna get x cubed plus x squared minus x cubed plus x squared. And on the bottom, I'm gonna get x squared minus 1. So the x cubed cancel out, so this is gonna end up being just the limit when x go to infinity of 2x squared over x squared minus 1. Now then, you can find the limit when x go to infinity. I'm actually gonna get infinity over infinity. So this is not too bad. I mean, this is not too bad. I can now use the L'Hopital's rule. You can simplify it using the basic method, but let me use the L'Hopital's rule here. Derivative of the top, that's gonna give me 4x. Derivative of the bottom, that's gonna give me 2x. 4x over 2x, that's gonna give me just 2. So that's gonna be my limit here. The next one, I'd like to find the limit when x go to 0 from the right of x times log of x. Well, let me try to find the limit here. So what happened when x goes to 0? X is, so that's going to be 0 times negative infinity. Okay. Now then, 0 times infinity, this is not something we can use L'Hopital's rule with. And even worse, I have x times log of x. This is not a fraction, so I cannot even use L'Hopital's rule here, so something funny is going on. But what I can do is, I can maybe manipulate this guy so that I have a fraction, so that I need to bring something to the denominator, so that I can now apply the L'Hopital's rule. So what I'm going to do is, I'm going to bring either the x or the log of x to the numerator, and hopefully that will allow me to use L'Hopital's rule, and that will finish the problem neatly. So let me try this. So that's going to be the same as, right, log of x times x is the same as log of x over 1 over x. Now you think about it for a second. If I divide log of x by 1 over x, I'm going to end up getting log of x times x. So this is the same thing. So somehow I bring x in the numerator to the 1 over x in the denominator, and this guy, because x is the same as 1 over x, so these two guys is the same thing. And now, if I try to find the limit of the numerator and the denominator, I'm gonna get log of 0 is negative infinity. 1 over x is gonna be infinity. So this is good. This is something I can use the L'Hopital's rule. So I'm gonna use L'Hopital's rule with this guy. So that's gonna be the limit when x go to 0 from the right of derivative of 1 over x. Derivative of 1 over x, that's gonna be, derivative of log of x. Derivative of log of x, that's gonna be 1 over x. Divided by derivative of 1 over x. Derivative of 1 over x, this is x to the negative 1, so derivative of that is going to be negative 1 x to the negative 2. So that's going to be negative 1 over x squared. Now, if you were to plug in 0, you'll get infinity over infinity. But you can see that this guy, it just looks the same. I can simplify this first before I take the limit any further. So let's see what is this. This is the same as the limit when x goes 0 of 1 over x times negative x squared over 1. So this guy is going to be the same as the limit when x goes to 0 from the right of negative x. Well, when x goes to 0, negative x is just going to be negative 0, which is 0. So that's my final answer there.